Ever looked at a 3D model and thought, cool,
Huh?
but what if it could also tell me when the project will finish or how much it'll cost? That's the magic of BIM dimensions. Think of them as layers of intelligence: 3D for design, 4D for time, and 5D for cost. In real projects, architects, structural engineers, and MEP teams all work on their own 3D models. Each model reflects their expertise: beams, ducts, walls, and pipes.
But how do they all come together?
So when these models are combined, problems often appear: a pipe cutting through a beam or ducts clashing with a ceiling. Through clash coordination, clashes are revealed, compared, and resolved. It's like assembling a puzzle where all the families finally fit. This is a must to get a single, reliable 3D model. A single source of truth that everyone can work from. A coordinated model. That's where 3D development ends, and it sets the stage for what comes next. Here's the catch. 3D shows what the building will look like, but not how it gets built. Construction is a sequence. Floors before ceilings, foundations before walls. A static 3D model doesn't capture that process. And that's why we need 4D. 4D links the 3D model to the construction schedule. Every element knows its start and finish date. Think of it like pressing play on a time-lapse movie. You see the building rise day by day. How is it built? The 3D model provides the what: walls, slabs, pipes. The project schedule from tools like Primavera or MS Project provides the when. In 4D, these two streams of information merge.
So, why does it matter?
Teams can see if two disciplines are scheduled to install things in the same space at the same time. For example, electricians and plumbers both needing the same corridor in week 5. They can test different build sequences. What if we finish the core first? Or what if we can pour slabs in zones? The model becomes a planning tool, not just a picture. So 4D changes the information flow from static design to dynamic construction strategy, helping you visualize construction, test alternatives, and optimize sequencing. Traditionally, cost estimation starts with QTOs and BOQs. In BIM, these already update automatically when the design changes. Change a wall in Revit and the BOQ adjusts. But is that enough? No, because 5D BIM takes it even further. It links the costs not just to design and materials, but also to time, tasks, and other resources like labor and equipment. For example, material costs can be tracked per floor in the 3D model, but 5D lets you track costs per task across time. Labor costs, equipment rentals can all be built in as per schedule requirements. The costs reflect real-world applications where we can choose fixed charges, daily rates and hourly rates, etc. Now this gives a true dynamic picture of project finances. Not just what materials you need, but when you need them, how much they'll cost at that stage, and how all costs interact over time. So we move on from dynamic construction to cost data and analysis.
So, what is 3D, 4D, and 5D BIM in a nutshell?
3D unites disciplines into a single clash-free model. And then 4D ties that same model to time, creating a construction playbook. And 5D integrates costs, making budgets dynamic and sequence-aware. Now together they turn BIM into more than just a modeling tool. It becomes a project management engine. The result: better coordination, fewer delays, and tighter cost control. Because today's successful projects demand more than just drawings. They demand data you can trust. And with 3D, 4D, and 5D BIM, you gain clarity, control, and confidence across the entire project lifecycle. Thanks for watching. Keep going. The journey is only just unfolding.